Did you know that metals can get tired too? It may seem strange, but it's true. Just like humans, metals can experience fatigue. This is known as metal fatigue. So, what exactly is metal fatigue? Well, it's the progressive and localized structural damage that occurs when a metal is subjected to repeated loading and unloading. This repetitive stress weakens the metal over time, eventually leading to failure. But why does this happen? Let's find out. At the microscopic level, metals are made up of tiny grains with distinct crystalline structures. These grains are held together by boundaries known as grain boundaries. When a metal is loaded, these grains start to deform and move. Over time, dislocations within the grains accumulate and interact with the grain boundaries, causing strain concentrations. This is where fatigue cracks begin to form. Fatigue cracks are like tiny cracks that start at the surface and slowly propagate through the metal. They may be invisible to the naked eye, but they're a ticking time bomb. As these cracks grow, they weaken the metal, making it more prone to failure. But how can we prevent or minimize metal fatigue? Well, scientists and engineers have come up with various strategies. One approach is to design metals with improved microstructures, such as by refining the grain size or controlling the distribution of alloying elements. Another strategy involves using surface treatments, like shot peening or case hardening, to introduce compressive stresses that can counteract the tensile stresses during loading. Understanding the secrets of metal fatigue can help us develop stronger, more durable materials. By studying the behavior of metals under different loading conditions, we can unlock innovative solutions to prevent catastrophic failures and improve the lifespan of metal components in various industries, from aerospace to automotive. So the next time you see a metal object, remember that beneath its shiny surface, there's a whole world of fatigue and material wear happening. Thanks for watching, and don't forget to subscribe to our channel for more fascinating insights into the world of materials science.